Hello and welcome back to another episode of Math with. So today we're going to be doing some Kuta software trig ratios. Ratios being the key word. There are several videos that I've made on this, and this one is going to be only the trig ratios. And there are three of them: sine, cosine, and tangent. Okay? And sine of the angle, this is an angle symbol, is equal to the opposite over the hypotenuse, if you did not know it. And cosine of the angle is equal to the adjacent side divided by the hypotenuse. And tan of the angle is equal to the opposite divided by the adjacent. And you may have heard from your teachers a fancy thing called SOHCAHTOA. Okay? So we're going to be going through several problems, and the whole idea of this is that eventually it will start to click. Okay, now the first thing we need to recognize is the angle is changing. So here we're looking at angle Z. So this is angle Z, and we need to identify first the opposite, the adjacent, and everything else. So it does not matter the fact that it says tan. We still want to go across from this angle. This is our opposite side. And then across from the 90-degree angle is always the hypotenuse. That goes across from the 90. And then I always label my adjacent last, which is whatever is left over, which happens to be next to, which is the meaning of adjacent, the Z. And because we are looking for tan, now we are concerned with opposite over adjacent. So tan of Z is just the opposite side, which is 21, over the adjacent side, which is 28. Now, 21 over 28 is 100% acceptable. However, most of the answer keys would simplify that fraction, so you just ask yourself, can it simplify? And if it does, then do that. What number can divide 21 and 28? And the answer is 7. 21 divided by 7 is 3. 28 divided by 7 is 4. So the better answer would be 3/4. Okay? Let's do another one. Cosine of angle C. Here's angle C. We need to go across from angle C to label our opposite side. We need to go across from the right angle to label our hypotenuse, and that means our leftover next to angle C is the adjacent. Okay, this time we're looking for cosine. Cosine is adjacent divided by hypotenuse, so that is going to be 16, because that's our adjacent, over 34. Now notice how these problems we are not solving, we are just writing the ratio in simplified form. And cos of C, in this case, if simplified, is 8 over 17 because they both divide by 2. Okay, let's stick in, they're being very considerate and keeping the angle in the bottom left-hand corner. So this time we have the opposite side here, same location for hypotenuse, and then same location for our adjacent. And this time it's sine. Well, sine, if you forgot, is opposite over hypotenuse. It's slightly off the page. That's how I rewrote it. So that would be 28 over 35. And again, both of these divide by 7. 28 divided by 7 is 4, and 5 for 35 divided by 7. Last one where the angle's in the same position. We got our opposite side here still, our hypotenuse, and then our adjacent. Do not be fooled. This is not always the starting angle. That'll change very shortly. So we're looking for tan. Tan is opposite over adjacent. So what is our opposite side? 32. What is our adjacent side? 24. You just fill them in. Okay? Now tan is the only one that can be bigger than 1, by the way. 32 is a bigger number than 24. Cosine and sine are always going to be smaller than 1 when fractioned out. 32 and 24 both divide by 4, and 32 divided by 4 is 8, and 24 divided by 4 is 6, which means that we could have simplified again. These both divide by 2, 4 over 3. We could have divided by 8 right away. 32 divided by 4 is 8, 24 divided by 4 is 3. Okay, the angle placement is changing. The angle placement is changing. Now the angle is over here, okay? So we got to be careful. This is the opposite side of that angle. And 34 is the hypotenuse because that is directly across from the 90-degree angle, which leaves 30 degrees for our adjacent, not 30 degrees, 30 for our adjacent side. Here we're looking for cosine of angle A. Cosine of A is going to be adjacent divided by hypotenuse. So that is going to be our adjacent, which is 30, and our hypotenuse, which is 34. So 30 over 34, or 15 over 17 when simplified. Moving right along, we're going to get through a lot of these today. We got sine of angle A. Angle A is over here. We go across from angle A. The only side that is not literally physically spitting out from that. See how the 24 is touching the A and the 40 is touching the A? Surprisingly, that's one of the hard things for students to get, is to realize this is across from it. The 24 and the 40 are not. Now the 90 across from that is the hypotenuse. Sine is opposite over hypotenuse. So I could label my adjacent, but I don't need it because it's only going to be the opposite, which is 32, and the hypotenuse, which is 40. 32 divided by, let's see, both of these divide by 8. You get 4 over 5 when you divide everything by 8. All right, keeping it going. I'm going to just do a lot of these. Here's your angle, angle Z. We're going to go across from that to label our opposite side. Across from the Y to label our hypotenuse. And then across from the X is the adjacent, but it is the opposite of X. So the adjacent of one angle is the opposite of another. That is an important feature in some cases. So here, let's do our math. We got opposite over adjacent for, opposite over hypotenuse for sine, and that would be 24 over 40, better known as 12 over 20, and 6 over 10, and 3 over 5. There's nothing wrong with simplifying 10 times if you have to. Okay, here is our angle C. This would be across from the angle C for the 14. And that means that our 50 is going to be our hypotenuse, and our 48 will be our adjacent. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse, so that's going to be 14 over 50. And I think that the only thing that we can divide both of those by is 2, which makes 7 over 25. Let's move on. We're going to do 2 more of these before we get a few on the backside, but the backside we're not doing all of them. Angle Z is up here. We go across from that to label our opposite side. We got angle Y opening up with the 90 degrees for our hypotenuse, and that makes the adjacent the 24. So cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse, toa. So that is going to be 24 over 30, which they both divide by 6 and make 4 over 5 again. All right. Last one on this side. We got angle C. Go across from that. You got our opposite. We got our hypotenuse. And we got our adjacent. Tan is opposite over adjacent. So this is going to be 27 over 36. Which both divide by 9, and that leaves you with 3 over 4. All right. Sometimes they don't want the answer as a fraction. I mean, that's rare, but sometimes you're gonna want your answer as a decimal, because these do, if you type them into your calculator, turn into decimals. All right, that's not completely unheard of. So we're gonna do 2 of these. Cosine, we still label our opposite even though we don't need it, because cosine is adjacent over hypotenuse. We need to label our hypotenuse, and we need to label our adjacent. So now we got 12 over 15. Okay, so cosine of Z is 12 over 15. Well, how are we going to write that to the nearest 10 thousandths? We utilize technology. I do not know what 12 divided by 15 is. Well, I might be able to figure it out. 12 divided by 15 is 0.8. That was easier than I thought it would have been. It's 0.8. So they're just looking for the decimal. You divide. Cosine of C, another cosine. We label our opposite over here, our adjacent, and our hypotenuse, just like we've been doing. And we need the adjacent over hypotenuse, so that's going to be 27 over 45. Adjacent divided by hypotenuse, just like we had for our last problem for cosine. And then you divide. 27 divided by 45 is 0.6. So we just write 0.6. If it was a rounding issue, then we would have to round to the nearest 10,000 according to the worksheet. The last thing that we have here is sine of 48. How do you find sine of 48? Well, this is going to lead us into the next video where we're going to be dealing with how do you solve these things. In order to find sine of 48, you just type it in your calculator and you get a decimal, which is 0.74, okay? Which is roughly equal to 3/4. So if we had sides of this triangle, maybe they would have been very close, but not equal to 3/4. So it shows that sides and the sines equal things, all right? Can sine of an angle ever equal 2? Remember that sine is always the opposite over hypotenuse, and the hypotenuse is always the biggest. So that means that we're always going to have a smaller number divided by a bigger number. And anytime you have a smaller number divided by a bigger number, it is always smaller than the number 1. It is always going to be a fraction. So the answer to that is no, because it's always going to be a smaller number divided by a bigger number. And perhaps 24, the hardest problem on the entire page. I'm surprised it's leaving us with this. We have, let's just call this angle x. We have sine, which is opposite and hypotenuse. So we need to fill in our opposite side of angle x is 1 and our hypotenuse is 3, but it wants to find cosine, which means we need to find the adjacent side out. Well, how are we going to do that? You got a few options. You could use the Pythagorean theorem, which is what I'm going to do. But you could have also actually used trig to do it if you know enough trig. But I bet you don't know enough trig yet. You're going to get there, but you don't know it yet. We find out that when we subtract 1, we get the square root of 8 as our adjacent side. And now we can find cosine of angle x is going to be the square root of 8 over 3, because it is our adjacent over hypotenuse. And that's going to do it for this one. Until next time, my friends, stay positive. In the next videos, we're going to be learning how to solve the sides of the triangles and the angles. I'll see you there. Bye.